Good evening, viewers. Today, I'd like us to tackle electrochemistry, and I'll divide it into three. I will only do this one question today. So I'll do electrolysis today, and the other days I will do the rest of the question. So we have this very simple question on the blackboard. I have this electrolyte, which it contains magnesium sulfate, aqueous. And then I only asked two questions. Name the suitable pair of electrode. And finally, state and explain the changes in concentration of magnesium sulfate solution as the process proceeds. So within this one question, I want to explain into detail what electrolysis entails. Now, when we have this question on the blackboard, whenever you see magnesium solution, magnesium sulfate solution, this aqueous means that water has been added. So when we take magnesium sulfate solid, when we add water molecule, it forms magnesium sulfate solution. So generally, whenever you see aqueous, it means water has been added. Therefore, in such a case, what will be the ions that will be present in magnesium sulfate? So I have a cation, and cations are positively charged ions, and I also have an ion, and anion are negatively charged ions. So in this case, we have magnesium ion and sulfate ion from magnesium sulfate. But again, remember, we dissolved it in water, and water contains the following ions: hydrogen ion plus hydroxide ion. So we have hydrogen ion from water and hydroxide ion from the same water. So when we have those anions and cations, let's come back to this diagram. So in this diagram, I'm having two things, this one and this one. They are normally called electrodes. These electrodes are just dipped into magnesium sulfate, and in this case, magnesium sulfate is called an electrolyte. These electrodes are made up of two things. It can either be graphite, and remember, graphite contains majorly element carbon, and then we also have platinum. So it can either be graphite or platinum. So graphite is very cheap, but platinum is expensive. Again, platinum is inert, it doesn't react, but at some point in time, at higher temperatures, carbon can oxidize into carbon dioxide. So in some cases where we may be requiring high temperatures or large amount of heat energy during electrolysis, we prefer platinum than graphite or carbon. And I hope we've answered this question. So when we have those two electrodes, I'd like us to understand what these two things entail. So when I have this, it actually represents a cell or a battery. The shortest side is normally the negative terminal, and the longest side is normally the positive terminal. Now, this positive terminal has been connected to this electrode, and this negative terminal has been connected to this electrode. And when magnesium sulfate is electrolyzed, it produces two gases, this one and this one, of which we will understand them later on. Remember, from the law of electrostatistics, like charges repel, but unlike charges attract. It therefore means that these cations, these two, they are positively charged, they will be attracted to the negative electrode. and this negative electrode is normally referred to as the cathode. So these ions, the cations, are attracted to the cathode, and the cathode is negatively charged, and these anions are attracted to the anode, and at the anode it is positively charged terminal. So this electrode represents the cathode, while this electrode represents the anode. So when we understand that, we are able to write the equations that takes place, equation for the reaction that takes place at the anode, and the equation for the reaction that takes place at the cathode. Now, these two ions, magnesium ion and hydrogen ions, are attracted to the cathode, but it is only one ion that normally gets preferentially discharged. And what do I mean by preferentially discharged? It is released from these two and attracted to the cathode, but only one is removed from the solution. Similarly, at the anode, when we have sulfate and hydroxide ion, it is only one that is preferentially discharged. Sorry for that. Now, we have factors that affect preferential discharge, and in this case, we are going to look at the position of the ion in the electrochemical series. I might not be able to draw all the electrochemical series, but when we look at the anion, hydroxide is below sulfate in the electrochemical series. It therefore means that hydroxide ion will be discharged, but sulfate ion will not be discharged. Similarly, when we look at the cation, hydrogen ion is below magnesium ion in the electrochemical series. Therefore, hydrogen ion will be preferentially discharged. What does it mean? Hydrogen will be discharged, hydroxide will be discharged, leaving alone magnesium and sulfate ion. Now, at the anode is where oxidation takes place, and at the cathode is where reduction takes place. And what do I mean by oxidation? So the best definition a Form 4 should have for oxidation is electron loss. So whenever an electron has been lost, we call that one oxidation. And on this other hand, reduction is electron gain. So whenever we have an ion gaining an electron, it actually undergoes reduction. Whenever we have an ion losing an electron, we call that process oxidation. So I normally prefer students to start by reaction taking place at the anode and to finish by the reaction taking place at the cathode. So what takes place at the anode? We say that the anode we have oxidation, and we say that it is hydroxide ions that are preferentially discharged. Therefore, hydroxide ion, when they are discharged, they produce water molecules, it produces oxygen gas, and also electron. And we need to balance the equation. How do I balance it? If I put 2 here, hydrogen will be 4. I put 4 here and also 4 here. So 4 electrons are lost at the anode. It therefore means that at the cathode, the 4 electrons that are lost must be gained at the cathode. Therefore, if hydrogen ion is preferentially discharged, it gains the 4 electrons to form hydrogen gas. But because of balancing, since we have 4 moles of electrons, here will be 4, so here will be 2. So we have 4 moles of hydrogen gas reacting with 4 moles of electron to give 2 moles of hydrogen gas. Similarly, 4 moles of hydroxide ion reacts to form 2 moles of water, 1 mole of oxygen, and 4 moles of electron. So at some point in time, you may be asked this question, to name this gas and to name this gas. Remember, at the anode, we had this one as the anode electrode. So what happens at the anode is electron loss. So this gas that will be produced at the anode is obviously oxygen gas. And the gas that will be released at the cathode is hydrogen gas. Now, from the look of the diagram, we have hydrogen gas being twice as much as oxygen gas. So the hydrogen gas is twice oxygen gas, of which you can clearly see here. Now, there is a law in mole concept where we have, when this one can be represented as 4 moles as well as 4 volume. So the same, we have 2 moles as well as 2 volume. This one we have 2 moles as well as 2 volume. Similarly, here we have 1 mole as well as 1 volume. And from this you can clearly see that 1 volume of oxygen gas is produced and 2 volumes of hydrogen gas are produced. And from that you can clearly see that hydrogen is twice oxygen. And that is how we tackle such a question whenever we are asked. Now let's try and see the last question we've been asked. State and explain the changes in concentration of magnesium sulfate as the process proceeds. Concentration of what? Magnesium sulfate. So we need to ask ourselves this question. Does the concentration increase or decrease? From preferential discharge, we've noticed from these two equations, hydrogen ion and hydroxide ion are removed or discharged from the electrolyte. What is left? We have magnesium ion and sulfate ion. It clearly states that, therefore, that magnesium sulfate concentration, magnesium sulfate concentration increases. And you can see from there, the reason being hydrogen ion and hydroxide ions have been discharged, leaving alone magnesium and sulfate ion. And at some point in time, you might be also asked the nature of the solution or the resultant electrolyte after electrolysis. Magnesium sulfate is a neutral solution. It therefore means when we dip red litmus paper, remains red. How about blue? Blue litmus paper remains blue. Why? Because it is neutral. We're remaining with magnesium and sulfate. Why is it not acidic? And why is it not basic? A solution is only acidic if and only if we have hydrogen ion. And a solution is basic if and only if we have hydroxide ion. And that is why we cannot say that magnesium sulfate is acidic nor basic. I think we have answered the question, and I hope you've understood them clearly. For the next class, I will proceed with electrochemistry. Thank you very much.